Okay, we're going to start with Module 2, Lesson 5, and we're going to look at those figures here. Is there a simple transformation that we know that would get this shape onto this shape? Would a translation work? Would a reflection work? Okay, we're going to be looking at how to make that happen with one simple transformation. Okay, and we're going to start off by talking about a couple of different things. We're going to look at this example, and we're going to be using your sheet protector to do this. So when we're talking about this specific transformation, this is a rotation. We're going to talk about rotation. Okay, we need to have two things for rotation. Okay, and I would write these down. The first thing you need to have would be a center of rotation. And you're going to need an angle of rotation. Okay, and in this problem, our center of rotation is going to be the O. And we're going to talk about specific angle of rotation here. We're going to do when the degrees is greater than or equal to 0. Okay, and when we do that, that means it's going to be a positive. Okay, it's a positive degree. Okay, and it's also noted like this: D is greater than or equal to 0. When the degrees is greater than or equal to 0, okay, and it's positive, you're going to move counterclockwise. Okay, so this is what this would look like. You take your paper, you mark your center, you draw your line, or whatever figure is, and you turn it. Okay, I'm going to go counterclockwise, and the main thing you need to make sure, one of the main things is you got to line up your center. So your center doesn't move, just the rest of your figure. Okay, so it would look something like this. Put it underneath, line it up. It could be as big of an angle measure as you want, or as little. Okay, I'm going to draw my line. This is P prime. This didn't really move, but we still relabel it, oh, not a Q, as O prime. Okay, and I even draw in which direction I went, so I know, okay, I went this way. Okay, now we're going to do the same thing for this example, except for this time our center of rotation, I'm going to write this over here. It is still going to be O, and our angle of rotation is going to be D is less than 0. So that's going to be a negative degree. Okay, and we're going to go clockwise. Okay, so it would look something like this. Okay, again, you mark your center and draw your line. You're going to rotate it clockwise, something like this. Your center stays lined up, and your figure is what moves. Okay. So we're looking at something like this. P prime, O prime, and it went clockwise like that. Okay, so now we're going to get in and do some examples on your paper. Okay. Organized here. Okay, so on number 1, it says, let there be a rotation of d degrees around center O. Okay, so our center is O. So our center of rotation, O. Let P be a point other than O. Select D so that D is greater than 0. So our angle of rotation, D is greater than or equal to 0. So that means we're going to go counter. Alright? So, just like before, we're going to line this up. We're going to go counterclockwise, just like that. So I'm just going to take it and put it underneath. Now you can go as much or as little counterclockwise as you want. Okay, that's completely up to you, whatever you're comfortable with. So this would be P prime, this would be O prime, and I went to that direction. We're going to repeat it again down here on number 2. Okay, this time we have our center and we have our angle. So our center of rotation is still O. Our angle of rotation is D is less than 0. So we're going to go clockwise. Okay. So we take our transparency, we mark our point and our line. We're going to keep the center lined up. Notice how I keep that lined up, and I went clockwise. So then you just take your paper or your sheet protector, put it underneath, draw your line, label it P prime, and show that you went clockwise. Okay, so now we're going to answer the questions on the back. Okay. Which direction did the point P rotate when D was greater than or equal to 0? Okay, D point P, you can see that, P moved counter clockwise. Which direction did point P rotate when D was less than 0? P rotated, and you could even put that there, rotated clockwise. Alright, so now we're going to look at an example when we have a circle. Still, O is our center, P is on the circle. Okay, so if we were to rotate that point P any amount of degrees, where would P prime go? Where do you think that P prime would land? Now, since it's a circle and a rotation mimics the movement of a circle, and this is the radius, okay, P prime would land somewhere on the circle. So here's what it would look like. Okay. Here's P prime. It moved here. Here's another example, P prime prime. It's the second time it was moved. And then there's a third example, P prime prime prime. That's the third time it was moved. Now, what if we looked at this and we moved it 180 degrees, positive or negative? Where would P land if we moved it 180 degrees, positive or negative? Okay, what would happen is that it would look something like this, and it would just make a straight line because the line is 180 degrees, so it would just rotate around to the opposite side of the circle and make a straight line, and that would be P prime. Okay, so now I'm going to show you another example. Okay, I'm not going to completely draw this one out, but instead of moving a point or a figure, we can also move just a point. So here, I'm going to say in pink, my center of rotation is going to be O, my angle of rotation is going to be D is greater than or equal to 0. So I'm going to go clockwise. So for this problem, okay, we're going to start here. We have K and J. Okay, so here it would go counterclockwise, just like this. Okay, and then, so it would go counterclockwise. If we were to change this and say that our center of rotation is still O and our angle of rotation is D is less than 0, we would just go clockwise. We can move our shape and our points clockwise, like that. Alright, so now what we're going to do is we're going to talk about this example here. Back to this. Now, at the beginning, okay, we asked what simple transformation this would be. It's not a translation, and it's not a reflection. Okay, this would be a rotation. And you can't just hold one down and get to the other. The center of rotation is outside of this. And to figure this out, okay, I'm going to go draw a line right through the middle this way. And I'm going to draw a line right through the middle this way. And where the lines intersect or bisect each other, right there, that would be my center of rotation, O. And if you look at this closely enough, it would be a right angle, 90-degree angle of rotation. And it could be a 90-degree positive, or it could be 270 negative and go clockwise. It would work either way. Now we're going to go to your packet, and we're going to work through the rest of those problems together. Okay, so this says, let L be a line, AB be a ray, CD be a segment, and angle EFG be an angle as shown. Let there be a rotation of D degrees around point O. So our center of rotation, O, and it says right here that our angle of rotation is D is greater than or equal to 0. So when it's greater than or equal to 0, that is counterclockwise. So we're going to take our transparency, I'm going to put it all on here. Okay, we're going to trace our line. Trace our segment, our other line, trace our segment, trace our angle, and our center. Okay, because it is D is greater than or equal to, we're going to go move it counterclockwise. The only thing that stays lined up is our center, which is O. Everything else will rotate counterclockwise. So then you would just take your paper or your sheet protector, put it underneath, line up your point O, and as long as you have moved it counterclockwise, you can just go ahead and trace. Now when you do this, don't forget to relabel your points, your lines, and your angles. This would be L prime, C prime, D prime, E prime, F prime, G prime, and you even relabel your center. Okay? So that's what it would look like when you rotate all of those things counterclockwise around your center O. Now, let's do, let me go back to it. So when you rotate something, if it was a segment, it maps to a segment or moves and becomes another segment. The word maps just means it moves it. If it was an angle, it became an angle once we moved it. If it was a line, it was a line once we moved it for both of those. Okay? Now we're going to move over here and we're going to look at this number 6. Okay? Let AB be a segment length of 4 units and angle CD be an angle the size of 45 degrees. Let there be a rotation of D degrees where D is less than 0 about your center O. Okay, so our center of rotation, O, our angle of rotation, D is less than 0. So that means we're going to go clockwise. Okay? So we're going to line this up to our point, our center, our line, and our angle. Okay, and we're going to go clockwise. So I'm just going to rotate it. Oop, that's not clockwise. Clockwise. Like this. Okay, and I'm going to take it. I'm going to put it underneath. Maybe if I can see there it is. And you don't really have to rotate it a whole lot. Just have to rotate it a little bit. Okay. So here's my angle. Ooh. This is D prime. This is C prime. This is E prime. And here's my line. A prime, B prime. Then the question asks, what is the length of the rotated segment, rotation AB? So that means, what is the length of the segment you moved? So if it was 4 units to begin with, it is still 4 units. So segment A prime, B prime is 4 units. What is wrong with this pen? Okay, and then it asks, what is the degree of the rotated angle? So it was 45 to begin with, so when we moved it, it was again 45 degrees. So angle C prime, D prime, E prime is 45 degrees. Okay, so when we rotate an angle or a segment, whatever the angle was, rotations preserve that angle measure, so this would be 45 degrees. And the same thing here, this was 4 units, so this length right here would be 4 units. Okay, and then we're going to move over and do number 7. It says, let L1 and L2 be parallel lines. They're parallel to each other. Let there be a rotation of D degrees, where D is greater than 360 but less than, or sorry, greater than negative 360 but less than 360 about O. And then it has a question. So first we need to identify our angle of rotation is any. You can move it any way you like. Our center of rotation is still, oh, you can't see this, it's still O. Okay, so if we were to do this, you would take these, I would have my point O, I would trace them here and here, and I would rotate it however I liked, clockwise or counterclockwise. It's completely up to you. I'm going to let you decide, and you draw it how you want to draw it on your paper. Okay, if I move this, okay, we have to go back and answer this question still. If I move L1 and L2, is L1 prime and L2 prime, are they parallel to each other? Yes. So we would write L1 prime and L2 prime are parallel to each other. And you can write it like this with the symbols. Okay, but make sure that you go through and you put this underneath and you draw what the actual rotation would be, what the translate or what the rotated lines where they would be, and also label them. L1 prime, L2 prime. Okay. So then on number 8, we have the same thing again. Okay. We're going to have a center of rotation is O, and an angle of rotation where it can't equal 180. So our angle of rotation cannot equal 180. You can do anything else but 180 degrees. And it asks, are the lines L and L prime parallel? Okay, so we have this. And we're going to draw our line. I'm just going to rotate it something. If I rotate it like that, is L so this is what it would look like if you rotate like this. You can rotate it however you want to. This is just an example. So this would be L, and this would be L prime. Make sure you label them. Okay. Are those two lines parallel is what the question is asking. No. L and L prime are not parallel. So for this question, L and L prime are not parallel. Alright, so make sure you go back and you draw this on your own for 7 and 8. Make sure you draw them. Now, rotations. Okay, you got to have a center of rotation and an angle of rotation. That's what this says. If it's positive, you're going counterclockwise. If it's negative, you're going clockwise. A rotation maps or moves a line to a line, a ray to a ray, a segment to a segment, or an angle to an angle. A rotation preserves length of segments, and a rotation preserves angle measures. When lines are rotated, when parallel lines are rotated, their image is also parallel. A line is only parallel to itself when it's a single line is only parallel to itself when it's rotated exactly 180 degrees. So let me show you what that means. Like if on here you rotate it a little bit, they're not parallel. But if you rotate it 180 degrees, those lines are now parallel. Okay?